In this experiment, we are going to discuss about the unknown capacitance by using the Sauty bridge. So, variety of bridges are there. You know, carry faster bridge. Through carry faster bridge, we are calculating a unknown resistance. Similarly, through Sauty bridge, we have to calculate the unknown capacitance. Capacitor, unknown capacitance, we have to learn. How we have to learn? Based on the balance principle only. First, we have to take it as a first to dish out to bridge. This is the capacitance of the bridge Taylor box I am taking. Right now, connecting wires. So these are the connecting wires, patch cards we are taking. These are the operators. Only bridge setup and operators we are taking. So what is the formula we have to see? First, to calculate the unknown capacitance. Unknown capacitance I am taking as a Cx is equal to R1 by R2 into C1. Clear? C1 is the known capacitance, R1 is a fixed resistance, R2 is the resistance at no sound we have to take. Clear? So this is the circuit diagram of the dish out to bridge. First, how we have to connect the bridge once we able to see. This is the power supply. Power supply I am connecting to ground to ground. Ground to ground I am connecting. Next, power supply AC to power supply AC I am connecting. Power supply AC to AC I am connecting. Now, you are going to take it as a speaker. The speaker one end you have to connect like this, and another end you able to connect like this. Another end you have to connect. Clear? So this is the speaker. Now inside you able to see inside. So R1, R2, two resistance are there. Capacitance C1 0.01 microfarad is there. Here Cx, that Cx is from here it is a variable unknown capacitance Cx. Unknown capacitance we have to calculate that one. Already fixed, one capacitance is fixed, that is 0.01 microfarad, right? The rest of the things, whatever the bracket lines are there, no, bracket lines, those lines you have to fill it. First bracket lines I am filling. So this is the bracket line I am filling. This is the continuous line. Already inbuilt there is a wire is there inside, right? So that's why you leave that one. Next, so there is a one more bracket line is there, one more bracket line inside that. I am filling that is, right? I am connecting to here to here. This is also bracket line is there, bracket line. So that is the bracket line. How I have to connect? So you able to do this one like this you have to do. Clear? You able to do. Here continuous line is there. That continuous line you have to leave it. So this is the bracket line. That bracket line, disconnected line, you have to connect here. This is the connection. Clear? So what we have to do? So we are following the procedure. So we are following the procedure. First, you have to keep the unknown capacitance 0.02. Here 3 is there, 0.22 microfarad, 0.33 microfarad, 0.47 microfarad is there. First, you have to keep as a 0.22 microfarad. I am keeping as a 0.22 microfarad. You switch on the power supply. So I am power supply, I switch on the power supply, right? So after switch on the power supply, there is a amplitude controller is there. This is the amplitude controller. You have to maximum you have to keep. So you keep the 0.22 microfarad. So this one is 0.01 microfarad is there. What is our formula you have to see? C1 by C2 is equal to R1 by R2. So R2 by R1. This is the formula. Bridge formula. So what is that formula? C1 R1 is equal to C2 R2. So our Cx is equal to Cyx is equal to 0.22 is divided by microfarad is divided by what is our fixed one C1 0.01 microfarad. This is the fixed one. Now you cancel it. How much you are going to get it? So you are going to get it as a 2 you are going to get. How you able to get the 2? So you able to see here 22 you are going to get 22. How you able to get the 22? This 22 whenever left hand side is 22, Right hand side also you able to get it as a 22. First you have to keep R2 as a fixed, you have to keep. How much? 2200 or 22,200 you have to keep R2. So 2200 you have to keep. First all you able to take it as a zeros. First you able to take the zeros, right? Zeros, I am keeping the zeros. First this is 1k, you multiplied with 1, 2. Sorry, 1, 2 you have to do. This is the 2000. And again you need to do 200. This is 100. 1, 2, 2200. Right? Now some sound is appearing. The speaker is will give some sound. So the sound will give the speaker. After this sound, minimizing, how much sound it is minimizing to maintain the 22, to maintain the left hand side 22 is there, no? Right hand side also you want to going to get it as a 22, means how much you want to keep. So up to that you have to change the R1. Here all are zeros you have to keep here. How? First you calculated it. 22,000 is divided by 22,000 is divided by 100 you have to take. 100 get cancelled. 22 you are going to get it. Clear? So that's why where it is 100, here 100 is there. You keep 100, immediately the sound should be minimized. Like that you have to do. This is the first set. Next CX you have to take it as 0.33. 0.33. So 0.33 is divided by, already 0.01 is fixed. Now you have to divide it, you able to get it as a 33. This is exactly equal to R2 by R1. R2 is equal to, now you have to set 3300 you have to keep. R1 up to the 100 you have to change. There is a sound is minimizing sound it will come. How you able to do? Already this is 2. One more time you have to increase. This is 200. One more time it is increasing 300. Now the sound is arising. To minimize that sound, sound is arising. To minimize that sound, you have to change. So 100 you have to change. So 100 you have to change. Not only that, so you able to take it 200 you have to keep, 300 you have to keep, so 400 you have to keep. So based on that, for 400 you have to keep R1. So how much you want to set to minimize this one to maintain the 33? So how you have to get it? So you able to find out 4 into 33 you have to keep it is 4 into 33. So 33 into 4, 4 3 ja 12. So 4 3 ja 12, 133, 100 you have 132. So 13,200 you have to keep. How you able to keep the 13,000? This is the 1000. You are going to keep it as a 10, right? So again, this one is 100 into 10. One more 1000, 10,000. So now 100 into 10 means, so 100 into 3 you have to keep 300. 100 into 1000, 3000 it will come. So now 100 into 100, 10 into 100. 10 into 100, 1000 it will come. Again you have to rotate this one. So like that you have to keep. So bigger value able to take. For corresponding that, you able to find out to minimize the resistance, to minimize the sound. That is the sound whenever is minimum, that time you have to stop it. Based on this one you able to do. So not only that, capacity, how many times is there? This is 0.02, 0.003, 0.47 you have to take. First time 0.22, 0.33, 0.47 you have to keep. Based on that, fixed, another capacitance is fixed. You able to calculate the minimizing resistance you have to calculate. Clear? One is fixed, one more is variable. Resistance is variable. So like this you have to balance that. So whenever the sound is minimized, that resistance you have to calculate. That resistance is a balancing resistance you have to find out. Clear? So like this you have to do in your table. R1 you have to take it as a 100. For R2 corresponding to R2, how much you able to calculated corresponding to the CX, that is 0.22 microfarad. Here you have to take 0.33 microfarad and 0.47, like that 4 table you have to make it. So then you able to calculate the mean value of the Cx. Mean value of the Cx you have to calculate. So our bridge is balanced. Through this balancing bridge, we able to calculate the unknown capacitance. How we able to calculate? Through the Sauty bridge, we calculated the unknown capacitance. This is the balancing principle. C1 R1 is equal to C2 R2, Cx R2. This is the balancing principle corresponding to the Wheatstone bridge principle. Clear? So please share, subscribe and like our YouTube channel. Like these videos we will upload in our YouTube channel. Thank you.